Good morning, everyone. Again, coming to the next lecture. Now we are going to see problems on all the types of dams. So, first one is a rectangular dam, a masonry dam of a rectangular cross section 10-meter height and 5-meter wide, have water up to uh, the top of one side. So, it is mean that the overall height is 10 meters. So, the total 10 meters is residing with the water. If the weight density of the masonry is 21.582 kilonewton per meter cube, find pressure force due to the water at the per meter length of the dam and resultant force and the point at which it cuts the dam. So let's see with this problem. Here capital H is 10 meter and small h is the same 10 meters and B value is 5 meters. Here given the weight density is 21.582 kilonewton per meter cube, which is nothing but weight density of the dam. So converting this kilo into the meter cube, so here the kilo will not come. It is 21,582 Newton per meter cube. And then the total pressure force is nothing but W into A into H bar. Already you know that this W is nothing but weight density of the water. So water, it is 9.81 into 1000 into, so this is going to be W, and the area is 10 into 1. Area is 10 into 1. Then 1 is nothing but the length, per unit length. You can see here it is per unit length. You can see that the 10 meter is the height and the 1 meter is length meter. So in the question itself it is given per meter length, so 1. And then h bar is 10 by 2. H bar is nothing but the CG point. So CG point, it is total h by 2, that is 10 by 2. So multiplying everything, you will get the total force, that is pressure force. Then the resultant force is nothing but square root of F into W square. So what is W? We have to find out the W. Weight is nothing but W naught into B into H into length is 1 meter. So total 21,582 into 10 into 5 into 1. So 109.100 Newton. So this is W. So after that we have to find out the resultant force. So this is the second problem. Then we have to find out this x distance, that is the resultant cutting at the base. X is nothing but the same formula, F by W into H by 3. So F will be, F value is substituted, W is substituted, and find the H by 3. Then total crossing thing is 1.51 meters. So this is for a rectangular dam. Let's see with another problem for calculating the stress value. So with the previous problem, that is the same problem, now we have given the another one. We have to find out the maximum and minimum shear stress. So there you have seen that E is equal to X for the rectangular beam. Already you have given that H is equal to 10 meters, B equal to 5 meters, and W naught here. F value is 490500 and W is 179100 and X value is 1.51. So here E value is equal to X value for in case of rectangular dam. So substituting these values, that is W by B into 1 plus 6E by B, we will get the total compressive stress of 606,885.84 Newton per millimeter square. So this is going to be compressive because everything is plus. So plus means compressive. And here W by B into 1 minus 6E by P, that is sigma minimum. So after substituting everything, you will get minus 175 245.84. Minus indicates it is a tensile stress. Minus indicates it is a tensile stress. So next problem we are going to see on the inclined trapezoidal, that is trapezoidal dam with vertical face. So this is the problem. A trapezoidal masonry dam is of 18 meters height. The dam is having water up to depth of 15 meters with a vertical side. The top and bottom width of the dam are 4 meters and 8 meters. You can see in the question itself, if they have given the top width, bottom width, and it is given vertical side. Vertical side means it is a horizontal, that is a flat side, not inclined side. So it will be a trapezoidal masonry. So here we have to find out, and then the thing, or top is 4 meters, bottom is 8 meters. The weight density is given as 19.62 kilonewton per meter cube. Determine the resultant force of the dam, and then point at which the resultant force cut the pace, and maximum and minimum stresses. So these are the things we have to find out. Here total height of the dam is 18 meters, height of the water is 15 meters, top width is 4 meters, and bottom width is 8 meter, and weight density is 19,620 newton per meter cube. Then total resultant force of the dam. First thing you have to find out the resultant force. You can see the diagram. This is how it looks. So this is how it looks. Here you can see that the force is W into A into H, and then substituting W is nothing but the water weight density 9,810, and then area is H into 1, and H bar is H by 2. After substituting, you will get 1103625, which is acting at a distance of H by 3. So here this 5 meters nothing but H by 3, that is 15 divided by 3 is 5 meters. Then total net weight of the dam, that is this trapezoidal shape's weight. So W is equal to weight density into volume. Volume of this trapezoidal shape is nothing but A plus B by 2 into H into 1. So this will be the total volume, that is A plus B by 2 into H into 1. 1 is length, H is height, and this is going to be the average width. So into W naught is nothing but your total weight, that is 211,8960 Newton. And then the distance of the line of action of W, that is we have to find out this N point from A point. So we have to find out this N distance. For that it is nothing but AN is, so we can calculate by two things. If you want to know the formula, you can easily substitute this formula for this trapezoidal, that is A square into AB plus B square divided by 3 into A plus B. By substituting this, we can find out the distance AN, that is A and N. So which will be 3.11 meters, and then resultant force R is equal to F square into W square, and this after that X distance. You can see that this is the X distance from N value to M value, that is X distance, which is nothing but F by W into H by 3. So it will be, after substituting this, 2.64604, and then the total distance. From this we have found out the X is 2.64, and then the total distance D value, you can see that the D value is nothing but AN plus NM, or this X, AN plus X. You have found out the distance of AN, that is 3.11 meter, and the X value is 2.604. So substituting these two, D is equal to, add both these things, that is 3.11 plus X, that will be equal to 5.714 meters. Now eccentricity is equal to D minus B by 2. In the previous rectangle, E is equal to directly X, but here E is equal to D minus B by 2. So here it will be 5.714 minus 8 by 2. So it will be 1.714 meters. So for the stress value, the same formula is here. Now we have to substitute the E value, that is the calculated E value 1.714. After substituting, you will arrive the maximum and the value of minimum. So with this type of problem gets over. So let's see with the another third type of dam and problem with that. You can see here it is a masonry dam of trapezoidal section, is 10 meters high, and its top width is is 1 meter and bottom width is 7 meters. The face exposed to the water have a slope of 1 horizontal and 10 horizontal. Calculate the minimum and maximum stresses at the base when the water level collides at the top of the dam. The weight density is 19.62 kilonewton per meter cube. So it is a third type of trapezoidal dam that is inclined on the both the sides. So first step, the given data, height is 10 meters, then height of the water is also 10 meters, then total top width is 1 meter, bottom width is 7 meter, and the depth of water is 10 meters. The side slope is 1 horizontal to 10 vertical, 1 horizontal to 10 vertical. Then the weight density of the masonry is 19,620 Newton per meter square, because this kilo is multiplied with the number. Consider 1 meter length of the dam. So for that, so first thing is we have to find out the Fx. So here you know that here F is converted into Fx and also Fy. Fx is equal to W into A into H bar. So which is nothing but 9,810 into 10 into 1. So 10 is nothing but the height into 1 is length, and this is height by 2. So total 490,500. Then the force Fx will be acting at the height of 10 by 3 meters, that is 1/3 of this height it will act. Then the force Fy will be calculated acting downward through the CG of the triangle AEC, the triangle AE and C. So this triangle it is acting, you can see that the Fy is acting along the CG of the triangle. So to find out that at a distance of 1/3 of 1 meter, you can see that uh, the total distance, that is A, and this value is 1 meters. You can see that it is 1 meter. How you can find out it is 1 meter? Because the slope of this inclined thing is 1 meter for every 10 vertical. You can see the total vertical distance is 10 meters, so the horizontal distance is 1 meter. So the CG point will be at 1 by 3 of meters. So weight of the dam is W naught into A plus B by 2 into H. So this is the total weight of the dam. Here W is the weight density of the dam or masonry. Then this is the volume, that is A plus B by 2 into H. So total weight of the W is 784,800. And then you can see that the position of the CG, this is the important thing. So here there is no formula, but you have to find out, like in the previous chapters, you have to consider this triangle and this triangle. So and then you have to apply the formula x bar. You have to find out the x bar is equal to a1 into x1 plus a2 into x2 plus a3 into x3 divided by a1 plus a2 plus a3, so that you can find out this G point from this A point. So with this they have found out it is 2.75 meters. And then So the then the d value, here d value is nothing but you can see that in the diagram. Now you have found out the distance between A and G, and then now you have to find out this D distance. To find out this D distance, we have to find out the X distance. So X distance, here it is also the same formula, and then adding that you will get the D value. After substituting the D value, you can see that the minimum and maximum stress can be found out using the eccentricity. So eccentricity is d minus b by 2, and then d will be so here d distance is 4.568 minus the b value is 7 by 2, so 1.068 meters is the e value. And then substituting here it will not be w, it is v is nothing but w plus fy. You have to add that, and then substitute. We will get the sigma max and sigma minimum. So this is the third type of problem. Thank you.